Good morning, students. Welcome back to your Max online class. Students, in your last class, you have learned some example problems related to onto function, one function. Am I right? Also, you have a homework question, exercise 1.4, sixth problem. I hope you completed that. Today also, we are going to deal with some problems related to one function, onto function and bijective functions. For that, before start our class, let us recall what is onto function, one function and this bijective function. Okay. So what is one function? A function f from a to b is called one function if distinct element of a have distinct images in b. I mean the different element of a have different element in b. This is one function. Then what is onto function? A function f from a to b is said to be onto function if the range of f is equal to the codomain of f. So range and codomain equal means we can say the function f is onto function. What is bijective function? If a function is one function also onto function, we can say that function is bijective function. So we are using only 3 types today. Now go to the problems. Exercise 1.1, fourth question. Show that the function f from n to n defined by f of x equal to 2x minus 1 is on 1 but not on 2. So a function is given, f from n to n is a function. This function is defined by 2x minus 1. We have to prove this function f is 1 but not on 2. So already we recall the definitions of 1 and on 2. This we can recall again. What is 1? Different element of the domain have different images means that is 1. Onto means if range is equal to codomain, we can say that is onto. Okay. Thus we can find out the elements. It is n to n. N to n meaning is set of all natural numbers. So 1, 2, 3 etc. Here also 1, 2, 3 etc. There is infinite numbers. We don't have to take all the numbers. Thus we can find out only 5 numbers. Given f of x equal to 2x minus 1. So f of 1, we can find out f of 1. F of 1 equal to, just substitute the value 2 into 1 minus 1. That is equal to 2 into 2, 2. Then minus 1, 2 minus 1 is 1. Okay. So 1 goes to 1. Then we can find out 2. Can you remember why are we doing this 1, 2, 3 etc.? Because set of all natural number means 1, 2, 3 etc. That is the reason we are applying. So thus we can apply in this place of x put 2. So 2 into 2 minus 1 that is equal to 2 2s are 4 minus 1 that is equal to 3. Then we can find out f of 3. So f of 3 equal to 2 into, just you can apply 3 minus 1 that is equal to 2 3s are 6 minus 1 that is equal to 5. Next we can find out 4. So 2 into 4 minus 1 that is equal to 2 4s are 8 minus 1 is 7. Next we can find out f of 5. Equal to 2 into 5 minus 1, 10 minus 1 that is equal to 9. So etc. You can put etc. because in n there are infinite numbers. So you can put etc. but we found only 5 numbers. Just using this we are going to draw the arrow diagram. So using the arrow diagram we can justify whether it is 1 or on 2. Okay. Just you can draw the arrow diagram. So it is n. This also n because our function is f from n to n. Okay, f. The values are 1, 2, 3, 4, 5, 6, 7, etc. In n, we have set of all natural numbers. Here the same 1, 2, 3, 4, 5, 6, 7, 8, 9, etc. Okay, because this is also set of all natural numbers. So then we can draw that. Look at a 1 goes to 1. So 1 goes to 1. Then 2 goes to 3. 3 goes to 5. 4 goes to 7. 5 goes to 9. So this is our arrow diagram. So using this arrow diagram, can you say whether it is 1-1 function or not? You can say it is 1-1 function, otherwise 1-1 function. Both are same. I am asking you whether this function f from n to n is 1-1 function or not. Yes, definitely it is 1-1 function because different elements in this domain have different images. Look at it, doesn't connect at the same image. So using this figure, what we can conclude that in this figure, different elements of domain have different images. So that implies definitely f from n to n is 1-1 function. Clear? So this is domain. This is a domain. Different elements of domain have different images. That is the reason it is 1-1. So in our question, what they are asking? You have to show this is 1-1 but not onto. So 1-1 we proved now. We have to prove it is not onto function. So how can you prove that? Using this figure. So if it is onto function, range must be equal to codomain. You know this is codomain. Range means the connected numbers. So here 1 is connected, 3 is connected, 5 is connected, 7 is connected, 9 is connected. But something are missing. Look. So definitely the range is not equal to codomain. So it is not a onto function. Also, the range is not equal to codomain. So that implies we can conclude that f from n to n is not onto. Clear? Next question. Exercise 1.4, fifth question. Show that the function f from n to n defined by f of m equal to m square plus m plus 3 is 1-1 function. So thus we have to prove it is 1-1 function. That's enough. They didn't ask about onto function. Just we have to find out this function f from n to n is a 1-1 function. So n to n, natural number to natural number. So natural number start from 1, 2, 3, etc. So infinite number of there. Just we can find out 5 values. So first write the given value. Given f of m equal to m square plus m plus 3. Okay. Next, we can find the value one by one. First we can apply 1. Next we can apply 2, 3, 4. Up to 5 we can find out. That's enough. So f of 1 equal to, here little change. Previous problem you had x, but in this place you have m. So in this place of m you can apply the value 1. So 1 square plus 1 plus 3. Now 1 square value is 1 plus 1 plus 3. 1 plus 1 2, 2 plus 3 equal to 5. So if you apply 1 you got 5. So 1 goes to 5. Next you can apply f of 2. So in this place of m apply 2. So 2 square plus 2 plus 3. So that is equal to 2 square value is 4 plus 2 plus 3. Add it to 4 plus 2, 6, 6 plus 3, 9. So 2 goes to 9. Next we can apply 3. So f of 3 equal to 3 square. In here apply 3 square plus 3 because it is m. So apply 3 plus 3. So 3 square means 9 plus 3 plus 3. Add it. 3 plus 3, 6. 6 plus 9, 15. Okay. Then f of 4 equal to, apply the value 4 there. So 4 square plus 4 plus 3 equal to, 4 square value is 16 plus 4 plus 3. 16 plus 4, 20. 20 plus 3, 23. Next we can apply 5. That is equal to 5 square plus 5 plus 3. Just I apply here. So when you apply, you will get 25 plus 5 plus 3. 25 plus 5, 30. 30 plus 3, 33. Okay, so just enough. Next we can draw the arrow diagram using these values. Okay, so I am drawing that now. So our function f is from n to n. So the values are, n means 1, 2, 3, 4, 5, 6, 7, 8, etc. Here also the same. It will start from 1, 2, 3. I am giving etc. because our first value is 5 here. So I can write 4, 5, then etc. Etc. means 6, 7 will come, 8 will come, then 9, etc. 15, etc. 23, etc. The straight draw to connect it. So our map will be 1 goes to 5. 1 goes to 5. So 1 goes to 5. 2 goes to 9. 3 goes to 15. 4 goes to 23. Okay. In this question, what they ask? In our question, they are asking, we have to show it is 1-1 function. How can we show it is 1-1 function? Different elements of a domain have different images, means we can say it is 1-1 function. Look at this figure. It is domain. Different elements of domain have different images. It not connected to the same image. All the images are different. So we can conclude it is 1-1 function. So first we have to write the definition. So from the figure, different elements of domain have different images. So this implies f from n to n is 1-1 function. Okay. Next one, exercise 1.4, sixth question. That's your homework question. I hope you completed that. Now we can continue the seventh one. Seventh question. In each of the following cases, state whether the function is bijective or not. Justify your answer. So you have to prove, you have to find whether these two are bijective or not. When we can say it is bijective? If a function is on1 and on2, you can say that is bijective. That means the function should satisfy both conditions. That should be on1, also that should be on2. Then we can say that is bijective. We can do one by one. First we can take first part. So what we are going to do, first we can prove that is 1 1. Next we can find whether that is onto or not. If that is both are 1 1 and onto, finally we can write this function is bijective function. So in 1 what is given? Given f of x equal to 2x plus 1. Look at the function f from R to R. R to R means set of all real numbers. It contains all values like positive, negative, 0, also the decimal value, everything. It contains all values, real numbers. So we are going to take only few values like -1, 0, 1, 2, 3. As your wish you can take. The reason is this contains all the values, interval minus infinity to infinity. So first I can take f of -1 equal to. So in this place of x we are going to apply -1. 2 minus 1 plus 1. Then that is equal to 2 into -1. Definitely our sign will be minus, negative sign. Then 2 into 1, 2. Also plus 1. So minus 2 plus 1. What will you get? It is a positive number. It is a negative number. So positive, negative. So you have to subtract and put the bigger sign, bigger number sign. So bigger number is 2. It has the sign minus. Your answer is -1. So -1 goes to -1. Okay. Then we can find out 0. F of 0. As you wish, you can take any value. Okay. This I am taking only few values. So 2 into 0. In the space of x, just I put 0 plus 1. That is equal to 2 into 0. Any number into 0, 0. Then plus 1. That is equal to 1. So when you take 0, it goes to 1. Then f of 1, I am taking the number 1. So 2 into, in this place x, I am putting 1 plus 1. So 2 into 1, 2 plus 1. That is equal to 3. Okay. Next one is I can take f of 2. That is equal to 2 into 2 plus 1. 2 2s are 4 plus 1. That is equal to 5. Now we are going to plot this in arrow diagram. So when you draw arrow diagram, it is R to R. R to R. Our function is R to R. So f from R to R. So definitely minus value will come. So I am plotting only from -2, -1, 0, 1, 2, 3, etc. Here also the same, etc. -2, -1, 0, 1, 2, 3, 4, 5, etc. Okay. Now we are going to draw it. -1 goes to -1. 0 goes to 1. 1 goes to 3. 2 goes to 5. So look at the picture. Every element of the domain, different element of the domain has different images. different images, so we can say it is 1 function. So I can write as different elements of domain have different images. That implies F from R to R is 1 function, otherwise 1-to-1 function. Next we can check whether it is onto or not. Onto meaning is range should be equal to codomain. It is the onto formula. But look at this. When you see this 0, 3, 4, you may think these numbers don't have pre-image. Already I told you, R means all, it contains all numbers. All numbers means including decimal value. If you put f of x, this is our given thing, f of x equal to 2x minus 1. If you put f of 0.5, it is R. R contains decimal value. Real numbers contain decimal value, so definitely we can put 0.5. So in this place of x, if you put 0.5, so what will you get? 2 into 0.5 minus 1. So when you multiply, what will you get? So 1 minus 1, what is your answer? 0. So if you take the decimal value 0.5, it is mapping to 0. So if 0.5 will be here, the 0.5 will be mapping to 0. So whenever, if you take any number from codomain, definitely it will have pre-image. So all the numbers are range in this domain. So definitely you can say also range equal to codomain. That implies F from R to R is onto. Now hence F from R to R is a bijective function. Okay, here only thing I took only the whole numbers, that is the reason these numbers seems to don't have the pre-image, but really all the numbers have pre-image. When you take the decimal values, definitely all the numbers have pre-image. Then you can put this onto, it is 1 and onto, then finally we can conclude F from R to R is a bijective function. So second part, we can go to the second part. F from R to R defined by f of x equal to 3 minus 4x square. So we have to find out whether it is bijective or not. For that, first we can check whether it is 1 and onto or not. Okay. So given, first what is given? F of x equal to 3 minus 4x square. It is given f of x equal to 3 minus 4x square. Okay. Next, it is R. R means set of all real numbers. It contains minus negative numbers, positive numbers, 0, also decimal numbers. It is the biggest, largest number system. Okay. So I am taking, first I am taking minus 1. If I take minus 1, the reason why is, it is the interval minus infinity to infinity. 3 minus 4, in this place of x square, this you can put minus 1. That is equal to 3 minus 4 into minus 1 square is, look at, you have to square the symbol minus, also 1. So when you square negative minus, you will get plus. When you square 1, you will get 1. So 3 minus 4, because 4 into 1 is 4. So 3 minus 4, you will get minus 1. Okay. Next you can check for f of 0. So 3 minus 4 into 0 square. 0 into 0 square is 0. 0 into any number? 0. That is equal to 3. You got 3. Next we can check f of 1. Apply. 3 minus 4 into 1 square. 3 minus 4 into 1 because 1 square is 1. That is equal to 3 minus 4. Subtract it, you will get minus 1. We can stop the process here because look at minus 1 have the image minus 1. Also 1 have the image 1. Sorry, minus 1. Both have the same image. 1 function definition is different elements in the domain have different images. But different elements in this domain have same image. We got same image. So it fails the condition 1, 1. So if it is fail in 1, 1, definitely f is not a bijective. Because bijective means if it is 1, 1 and onto, we can say it is bijective. It is not 1, 1. Then how can you say it is bijective? It is not bijective. So here 1 comma minus 1 have the same image minus 1. So that implies f from R to R is not 1, 1. So if it is not 1, 1, f from R to R is not bijective. Okay, here we proved it is not a bijective function. 8th question. So this class last question. Let a equal to set of all minus 1 comma 1, b equal to 0 comma 2 if the function f from a to b defined by f of x equal to ax plus b is an onto function. Two sets are given. The function from a to b is onto given, but we have to find out what is a and what is b. Okay, so how we are going to solve? Listen it. First we can write what is given in the question. Given a equal to, set a equal to minus 1 and 1, then set b equal to 0 and 2. Also given f of x equal to ax plus b. These are given in the question. One more thing is given, it is onto. It is an onto function. So what is the meaning of onto? Onto meaning is range equal to codomain. Range equal to codomain. That meaning is all the elements in the codomain have the pre-image. All the elements in the codomain have the pre-image. This is the meaning. So if it is onto function a to b, sometimes this f minus 1 may map to 0. If minus 1 is mapping to 0, 1 is mapping to 2. In other case, if minus 1 is mapped to 2, sometimes this 1 may map to 0. These are the two possibilities, but we don't know what was. We have two possibilities, so I can take this as, I am taking this, okay, this possibility first. Next we can prove the next one. Let f of minus 1 equal to 0. That means minus 1 is mapping to 0. Also f of 1 equal to 2. The meaning is f of 1 is mapping to 2. Okay. So in this place of x, we are going to apply minus 1 now. Okay. In this place of x. So if you put minus 1 here, here also you have to put minus 1. So a into minus 1 plus b equal to 0. Just apply here. Then multiply it minus a plus b equal to 0. So take it equation number 1. The same thing we are going to do here. So f of x equal to this one. So what is f of 1? So a into 1 plus b equal to 2. Okay, a into 1 is a plus b equal to 2. Take this equation number 2. Now we can add equation number 1 and 2. So we are going to solve it. So 1 implies minus a plus b equal to 0. 2 implies a plus b equal to 2. So 1 plus 2 implies we are going to add. So it is positive, negative. Both will cancel. Then when we add the both are positive signs. So b plus b, 2b equal to 0 plus 2, 2. So b equal to 2 by 2. Am I right? Then cancel it. Using 2 table, you got b equal to 1. So now you got b equal to 1. Just you can apply the value in equation number 1 or equation number 2. Okay. And just I apply in equation number 2. So apply b equal to 1 in, apply b equal to 1 in equation number 2. Just you can apply in equation number 2. So 2 implies a plus, in this place of b just put 1. 1 equal to, there you have 2. Okay. Now a equal to, bring that 1 there. So 2 minus 1. That implies a equal to 1. Okay. So just we found out, hence a equal to 1, b equal to 1. So if you choose this way, if f of minus 1 equal to 2, f of 1 equal to 2, you will get the same answer. A equal to 1, b equal to 1. Okay, you can check it. So that's all today's portion. So students, just study this portion, take your notes, okay.